We have here a graph. It's a graph of a proportional situation. Well, you might say, how do I know it's a proportional graph? Well, I know because it starts at 0, passes through the origin, and goes up at a constant rate. Now, in the past, we've told you how to find the slope of such a line, so you just find any 2 points on the line. So let's pick out a couple of points here. And then we just calculate the rise over the run to get from one point to the other. In this case, we're actually rising 2 steps for every 1 step we go across. So our slope would be 2 over 1, which we could simplify to be 2. Well, another thing that makes it proportional is that if we look at any one point as well, let's say this one, if we look at the x and the y value, we know that the x value is 3, the y value is 6. If we make a ratio of the y value over the x value of that point, guess what we get? We get 2 over 1 again. So we get the same thing as we get as when we did the slope. So because both of those numbers and those relationships are equal, this is considered to be proportional. Now, if the line did not pass through the origin and shifted up or down a little bit, then if we tried to make this same comparison, it wouldn't work. So, moving forward then, a proportional relationship. A relationship is proportional when the ratio of y over x is a constant, which we just showed a moment ago. The rate of change describes how one quantity changes in relation to the other quantity. We talked about the slope. In the proportional relationship, the rate of change is equal to the constant of proportionality, k. So what we're trying to say is that the slope is the same as the ratio between y over k, or y over x, excuse me. Okay, so let's just kind of see how this works then. We've got this first one where we know that Kevin earns $30 an hour for the work that he does, which is pretty good pay, isn't it? So we're going to calculate some values for 4 hours of work, 8 hours of work, 10 hours of work to see what the output or how much he's going to earn from that. So we do that by multiplying. So for 4 hours of work, he gets $120. 8 hours of work, $240. 10 hours of work, $300. So if we plot it on the graph, oops, jumping the gun there. If we plot it on the graph, we start out at 0, 0. No work, no money. 4 hours up to $120. 8 hours up to $240. And then 10 hours up to $300. So we've got a line that starts at the origin and has a constant rate of change or constant slope. So there's an example of a proportional relationship. Okay. Next, we have Jose, who saw a magic trick online that used magnetic marbles. He wants to buy a set of those marbles so he can perform the trick himself. The marbles are sold in different sized sets. A set of 120 marbles costs $114. A set with 160 marbles costs $152. And a set with 220 marbles costs $188. So we want to know if this is a proportional relationship, or if you're getting the same value per marble, if you will, in each set. So how do we find out? Well, we divide the cost of each set by the number of marbles, and that will tell us if we get the same ratio, or we'll actually find out how much it costs per marble. And if that's the same price, then it's considered proportional. So let's do our dividing. And the first two, 114 divided by 120 is 0.95, or 95 cents a marble. The same with set 2, 95 cents a marble. But set 3, for some reason, they're charging a little bit more. That's 99 cents per marble. So this would not be a proportional relationship. Okay, what about, let's try another example. Diane trained 3 racehorses. She trained one for 20 months, another one for 50 months, and a third for 70 months. Keep in mind that it costs a lot of money to train those horses. So we want to know is if training those horses, those different amounts of time, was a proportional relationship. So to do that, what we're going to do is we're going to divide the number of races they won by the number of months that they trained and see what kind of a final value we get. So 18 divided by 20, 45 divided by 50, 63 divided by 70. So let's see what we get. When we do those divisions, we end up with 0.9 each time. So by training it longer, we don't win more than 90% of the races. Whatever length of time that we trained, we won the same percentage of races that we entered. So that is considered to be proportional. Okay, next, Kayla is filling up her pool with a hose. The pool starts out empty, and then the hose pumps 75 liters of water in every minute that it runs. Let X be the time in minutes, and then that the hose runs, and let Y be the amount of water in liters in the pool. So our equation for this then would look like that. Y equals 75x, or I could have put in f of x equals 75x, couldn't I? Put it in function notation form. All right, so now what we want to know is if we start filling the pool, what would our graph look like? Well, at time 0, there's no water in the pool, so that would be a 0, 0. In 1 second, we would have 75 liters in the pool. In 2, we'd have 150. And in 3, 225. And so you can see here's our graph of that information. So because it starts at the origin and it moves up at a constant rate of change, the graph it goes up through the origin, and the relationship is proportional. If you read the other statements, you can see that in one way or another they are not true. Okay, now this last one we're going to look at 3 balloons. Each balloon has a little statement by it that talks about how fast it's rising above the ground, okay? So the first balloon, balloon A, is rising at a rate of 320 centimeters every second. So 320 centimeters per second. The second balloon, if we look, we notice that as seconds go up, this number goes up by 310. So this is rising at a rate of 310 centimeters in a second. And in our last balloon, just by looking at the graph, we can see that in 1 second, this one has risen 300. So this is 300 centimeters a second. So the fastest balloon then would be balloon A, because it would have gone up 320 centimeters. So if we go out 2 seconds, how far would each balloon go? Well, we just have to double these numbers. So the first one would be 640 centimeters high. The next one would be 620 centimeters high. And the third one would be 600 centimeters high. That's in approximately 2 seconds. So there's some proportional relationships and how they worked. So our assignment is just to do a few problems like that, maybe a couple of review questions. It'll be number 47, applying proportional relationships on Alex. So good luck with that, and thank you very much.